Hi everyone, welcome to our video on using partial derivatives to find or to evaluate certain functions when it involves an application. Alright, so let's read this. So it says the cost to produce a dog toy is approximated by c x comma y equals 10x squared plus 4xy plus 2y plus 100, where x is the cost of the squeakers and y is the cost of labor. Find the following. Okay, on this is just an evaluate. The first one is not even doing any derivative. This is just saying plug in your 5 into your function there and your 2 into this function. So it's using the original function, so no derivative yet. So this is 10 times 5 squared plus 4 times 5 times 2 plus 2 times 2 plus 100. Okay, so now it's just order of operations. So it looks like this would be 10 times 25 is 250, plus this looks like this becomes 40 plus 4 plus 100. Okay, so all of this simplifies into 394. And we'll assume it's in dollars. Okay, so 394. Okay, so what this means is this, so this is the cost to produce. Okay, so x is the cost of squeakers, so 5 squeakers. 5 squeakers. Put that A there. Okay, so squeakers. To produce 5 squeakers with, I guess, 2 people of labor and 2 people for labor. So I'm assuming that, so they didn't really give us the units there. I'll assume that means 2 people were involved to make this. Okay, so that's that. Okay, so maybe it's an expensive dog toy, who knows. All right, but that's what it costs to produce it. All right, so that's just plug in and evaluate. Now in number 2 here, let's use blue. So this is the partial derivative with respect to x. So really, first thing we want to find is our partial derivative with respect to x, and then afterwards we'll plug that 2 and 3 in. Okay, so looking at our function, remember we're treating everything with an x in it as a variable, and then y is just a constant. So the derivative of 10x squared would be 20x. The derivative of 4xy would be 4, and then the derivative of x is 1, and then y is like a constant where it's just attached. And then plus, well, the derivative of 2y would be 0 because it's treated like a constant. And then plus the derivative of 100 is also 0 because it's a constant. Okay, so let's simplify this. Okay, so this is our partial derivative with respect to x. So it looks like that. So 20x plus 4y. And then now we can plug in, so step 2, now we can plug in the 2 and the 3. And just make sure they're going in the right spot. So our x-coordinate is going in there, and then our y-coordinate is going in there. Okay, so then we've got 20 times 2 plus 4 times 3. And then we can simplify this. This is 40 plus 12. So let's just go ahead and say that that's 52. And then this is still in dollars, but it's with a derivative, so it's $52 per whatever the derivative variable is. Okay, so we're looking at our x. Our x was squeakers, so per squeakers. Okay, so it means $52. So it's still always a rate of change. So the derivative is still a rate of change. So this represents $52 per squeaker when they have 2 squeakers being produced and 3 people working on it. Okay, so that's all it's saying. So and what it really kind of means too in another phrasing is it would cost $52 more, or $52 for 1 more squeaker. So to make a 3rd squeaker would be let's say it again. So to make another toy with 3 squeakers would be $52. Okay, so but that's really all it is just make sure it's still a rate, so something per something. Okay, and then in number 3, they wrote it in the different form. So what this really is, you could rewrite it too if you prefer. So this is del c del y, which is really saying find the derivative of your cost function with respect to y. So you could change it if you don't like this notation. And then that way, let me go to green actually. So that's what I've been doing with these types of problems. So with respect to y, so what we really need to do is find this first. There we are. And then let me just scroll so we can see it. So we're using this function here still, but we're doing it with respect to y, so that means treat x like a constant. So the derivative of your first term there, that's treated like a constant. Okay, so that means it's 0. And then we have the derivative of 4xy. Well, that would be plus 4x, and then the derivative of y is 1. And then we have plus the derivative of 2y would be 2, so plus 2. And then the derivative of 100 is still a constant, so the derivative of a constant is still 0. Okay, so it looks like our partial derivative with respect to y simplifies to be 4x plus 2. All right, so then to evaluate what they want, so I'm going to write it as del c del y of 3 comma 5 is the same thing as our partial derivative of y at 3 comma 5. And then, well, I'm going to plug in the x-coordinate right there. And then, well, there is nowhere to put the y-coordinate. That's okay, though. So we'll just plug it in as 4 times 3 plus 2. And then this simplifies to give us $14. And then it's per whatever the variable is for the partial derivative. So is with respect to y. So $14 per, I guess I'm just going to say worker. Okay, so $14 per worker, since the y is the cost of labor. So again, I'm assuming that means like per person. Okay, so $14 per worker. So again, what that kind of means in words is to produce one more toy, when you have three squeakers and 5 workers, it costs $14 per worker added. So if they went to a 6th worker, this is how much the cost should change. Okay, so that's it. So that's how we break these down. So it's really just making sure it's still a rate, so per something. Okay, notice this one was not a rate. This was just the dollar amount because we didn't do a derivative yet. All right, anyway, so if you do have questions, though, please let me know. Otherwise, thanks for watching, and I'll see you again next time.